How do you find the volume of a cylinder? For example, a cylinder with height 7 centimeters and radius 2 centimeters. In this lesson, you will learn how to develop and apply the formula for volume of a cylinder by using the concept of stacking circles. Let's review. You already know that the volume of a rectangular prism is given as the base area times the height. This is often represented as volume equals big B times H. And if we take the base area of a rectangular prism and we fill the prism with that base by stacking it higher and higher, we fill the prism and we get the volume. So in this case, we would take the base area of 6 centimeters squared and multiply it by the height of 4 centimeters, and this would give us 24 centimeters cubed. The same concept applies for triangular prisms. You also know that the volume of a triangular prism is big B times H, the base area times the height, and if we take the base area and we fill the prism with that base area, it gives us the volume. In this case, we have 4 centimeters squared as the base area. We multiply that by the height of 5 centimeters, and that gives us 20 centimeters cubed. Let's also review the formula for the area of a circle. The area of a circle is given as pi times the radius squared. So in the case of a circle with a radius of 3 centimeters, the area would be pi times 3 centimeters quantity squared, which gives us 9 pi centimeters cubed. So let's look at our main lesson here. The volume of a cylinder is very similar to the volume of a rectangular or a triangular prism. We simply take the volume is equal to the base area times the height. And in this case, if we have a general height of h and a base area as a circle, so the base area is pi r squared, we get the volume of a cylinder, again by filling the cylinder with bases, will be pi r squared h. Let's look at an actual example. Going back to our original example, a cylinder with height 7 centimeters and radius 2 centimeters, if we apply our formula that we just developed, volume equals pi r squared h, we can substitute in 2 centimeters for the radius and 7 centimeters for the height. Now this gives us 28 pi centimeters cubed. How do you find the volume of a cone? For example, a cone with height 9 centimeters and radius 2 centimeters. What would be the volume of this cone? Well, in this lesson, you will learn how to develop and apply the formula for volume of a cone by comparing cones to cylinders. Let's review. You already know how to find the volume of a cylinder. If the height is h and the base area is b, capital B, then the volume is given as base area times height. Or, in the case of a cylinder, the base is a circle, so V equals pi r squared h. Let's look at how this can help us find the volume of a cone. Let's take a cylinder, as we just looked at, with height h and base area pi r squared, and then let's look at a cone that's very similar, that would fit perfectly inside of the cylinder. So the cone would also have base area pi r squared, and it would have height h. Question is, what would the volume of this cone be? It's pretty obvious that it will be less than the volume of the cylinder, but how much less? Well, let's look at the relationship between the cone and the cylinder. Let's say, for example, we were to fill this cone with sand, and let's say we were to pour the sand into the cylinder. How much of the cylinder would the cone filled with sand, how much of the cylinder would that fill up? Well, the answer is that it would actually take 3 cones to perfectly fill the cylinder. So it takes 3 cones to fill one cylinder with the same radius and height as the cone. This will help us now determine the formula for volume of a cone. So here again we have the cone and the cylinder with similar dimensions. The volume of the cone is 1/3 of the volume of the cylinder because it takes 3 cones to fill the cylinder. So, since the volume of the cylinder is pi r squared h, we can now conclude that the volume of the cone is 1/3 pi r squared h of a sphere. For example, how do you find the volume of a sphere with radius 3 centimeters? Well, in this lesson, you will learn how to develop and apply the formula for volume of a sphere by comparing spheres and cylinders with similar dimensions. Let's review. You already know how to find the volume of a cylinder. If the height is h and the base area is represented by capital B, the volume of a cylinder is base area times height, or V equals pi r squared h, because the base is a circle and the area of a circle is pi r squared. Now, let's apply that to a cylinder that has a radius of r and a height of 2r. In other words, the height of the cylinder is equal to the diameter of the cylinder. So, the volume would be pi r squared h, and if we substitute in r for the radius and 2r for the height, we get pi r squared times 2r, or 2 pi r cubed. Now, how will this help us find the volume of a sphere? Well, if we take a sphere that has very similar dimensions, in other words, a sphere that has the same diameter as the cylinder, and so the height of the sphere is equal to the height of the cylinder, we find that this will actually help us figure out the volume of the sphere, which is what we want to know. So let's look a little further. Here's our same cylinder, and what we want to do is look at what would happen if we poured a hemisphere, or half of a sphere, into the cylinder. So let's say we had a hemisphere filled with sand. What would happen if we poured the sand into the cylinder? How much of the cylinder would it fill? Well, one hemisphere would fill about 1/3 of the cylinder, and so it would take 3 hemispheres, exactly 3 hemispheres, to fill the cylinder to the top. So 3 hemispheres equal 1 cylinder of equal radius and height 2r. What does this mean for us? Well, if this is our hemisphere and this is our cylinder, and we know the cylinder's volume is 2 pi r cubed, well, we know if the volume of the hemisphere is 1/3 the volume of the cylinder, then the volume of the hemisphere must be 2/3 pi r cubed. Now, what does that mean for the volume of a sphere? Well, a hemisphere is half of a sphere. So, if we take half of a sphere, and we know its volume is 2/3 pi r cubed, then we must have to multiply that by 2 to get the volume of the sphere. So, we can conclude that the volume of the sphere is 2 times 2/3 pi r cubed, or simply 4/3 pi r cubed.